Alright, y'all guys. Alright, y'all guys, man. Alright, y'all guys, man. So the power just went out because there's a storm or something, but we should be back now. Hold up. Hold up, guys. Let me just open up my channel and okay, we should be back now. Let me just check. Yeah, my bad, guys. There's a storm brewing outside, and like um, my internet went out. Okay, we should be back now. Let me just check. Okay, also we seem to be back. My bad on that one. So, all right, we are back. Let's continue. Let's continue. Okay, so where was I? So we were on problem short sort. We are on this problem. So there are three cards with letters. Okay, let me just check the stream. Okay, there are three cards with the letters A, B, and C placed in a row on some order. You can do the following at most once. Pick two cards and swap them. Is it possible that the row becomes ABC after the operation? Output yes if it is possible, no otherwise. The first line contains T, the only line contains A, B, and C. So this is three letters. Three letters. And they should be distinct letters as well. So as we can see, we can perform this swap operation. We can perform this. What happened here? We can perform this swap operation at most once. So right here, we don't need to perform it, so we get A, B, and C. That's true. So that's a yes. Then we have A, C, and B, which we perform the swap operation once, and this becomes A, B, C. So that's a yes. We have B, A, C, which we perform the swap operation once by swapping B and A, and this becomes ABC. Then we have BCA. So if we swap B and C, it will be CBA. If we swap B and A, it will be ACB. If we swap C and A, it will be BAC. So in this case, we can't get the desired output with the swapping. So yeah. Okay, so in the next case, CAB, if we swap C and A, it's ACB. If we swap C and B, it's BAC. If we swap A and B, it's CBA. We can't do that. But in here, in the last one, it also is valid because if we swap A and C, it's gonna be ABC. Okay. All right, that's basically the logic. Now, how have I implemented this in code? So I'm gonna search through my short sort. So this is how I have implemented it in code. Okay, let me. Great, thanks gaming Annie YT. Thank you. So this is how. So we get the test first. We get all the test cases. Then we're gonna run this as many test cases we have. Then I'm going to take in the string, which is ABC. Okay. Then if basically if they are in the correct order already, so basically if we don't need to perform any swaps at the beginning, if the first character is A, the second is B, and the third is C, we're just gonna see out yes, and then we're gonna continue on to the next iteration. So then I copy S, so I can swap the characters in the original string. Okay, because yeah. And now, if now after swapping we get A, B, C after each other, then we see out yes and we continue on to the next iteration. Otherwise, I'm going to set S to S2 because in the original S I have swapped, and then I want to use the one I got as input again, so I'm gonna do it in S2. Then again, we've already swapped the zeroth in the first index, so now we're gonna try to swap the zeroth in the second. If now the characters are A, B, C one after the other, then we're going to see out yes and continue. Otherwise, we get the original string again, and we do the last swap possible, which is swapping the first and second characters. If now we have a correct string, then we're gonna output yes. Otherwise, that means that it is not possible to obtain what we want after just one operation. So then we will see out no. Okay. How do you stay motivated? Hey man, I'm gonna drop some game on you right now, bro. Even when you're not more, because motivation is temporary, bro. You gotta work even when you're not motivated. I mean, it's gonna be hard, but that's what separates the 1% from the 99%. You gotta work. You have to put in the work even when you don't feel like it, and that's how you're gonna get ahead. Okay, so that one is done. So let's mark this. And next one is lead code. This one is actually interesting because it is a greedy. This is a greedy problem. As you can see, the tags are greedy. Okay, so guys, in greedy problems, we often use sorting. We often use sorting in greedy problems. So this is the problem. So um, okay, I'm gonna try to draw for this one a little bit. Maybe I'm gonna draw for this one. So problem is this one. Lead code. Okay. Actually, I'm gonna shorten it a little bit because it's taking up too much space. Okay, so that's the current problem. So what's the statement? There are n available seats and n students standing in a room. You are given an array seats of length n, where seats of I is the position of the ith seat. You are also given the array students of length n, where students of j is the position of the jth students. You may perform the following move any number of times. Increase or decrease the position of the ith student by 1, meaning moving the ith student from position x to x plus 1 or x minus 1. Return the minimum number of moves required to move each student to a seat such that no two students are in the same seat. Note that there may be multiple seats or students in the same position at the beginning. So basically, what do we have to do? How do we solve this? Okay, so the students are moved as follows. The first student is moved from position 2 to position 1. Okay, because basically position 1 using one move. So how many moves? So return the minimum number of moves required to move each student to a seat such that no two students are in the same seat. Perform the following operation: increase or decrease the position student by 1. Okay, this is the operation we perform. We're gonna increase the ith student by 1. So plus 1 or minus 1, and this is, we have to count how many minimum operations we need to do. So how many minimum times we have to increase or decrease the number in order to get the other number. Okay, so the first student is moved from position 2 to position 1 using one move. So as we can see, this is 1, this is 2. We increment this by 1, and this is gonna be 2. Okay, the second student is moved from position 7 to position 5 using 2 moves. So as we see, here we have 5, here we have 7. To get to 7, we need to add 2 to 5. So we're gonna increment 5 by 1 twice, and that's gonna become 7. The third student is moved from position 4 to position 3 using one move. So it takes us one move or one increment to increment this to become 4. So both of these are 4 now. Okay, then we have the second example. The minimum is 7 operations. The minimum is 7 operations. So the students are moved as follows. The first student is not moved because we already have a seat, which is 1. But the second student is gonna get moved to 4, as we can see, and exactly it says it here. The second student is moved from 3 to position 4 using one move. Okay, so 3 plus 1, it makes 4. All right, and that is the minimum move we can perform, because we can also move this student to 5. We can move it to 9, but moving it to 5 is gonna be 2 moves, so we don't do that. That's not optimal. So in greedy problems, we take the best option which we have right now at the current moment. So the best option right now would not be to increment 3 by 2 to get 5, or by 6 to get 9. It will be to increment 3 by 1 to get 4. Okay, then the third student is moved from position 2 to position 5 using 3 moves. So we increment 2 by 3, and that gives us 5. And then finally, the fourth student is moved from position 6 to position 9 using 3 moves, because basically if we add 3